The universe has a way of keeping us humble. Just when we think we understand the rules of the cosmic game, something comes along that challenges everything we thought we knew about our place in the infinite darkness. And that something might be hurtling through our solar system right now, carrying secrets that could fundamentally reshape how we understand life itself. What I'm about to share with you is the story of 3I/Atlas and why NASA's official position on this mysterious visitor might be missing something far more profound and unsettling than anyone in the mainstream scientific community is willing to admit. This isn't about conspiracy theories or wild speculation. This is about the uncomfortable gap between what we observe and what we're willing to believe. A gap that has defined human scientific inquiry since the very beginning of our civilization. Let me take you back to the moment everything changed. It was October 2017, and the world was buzzing with anticipation about a discovery that had just been made. For the first time in recorded history, astronomers had detected an object from outside our solar system, crossing through our cosmic neighborhood. They named it 1I/Oumuamua, and it was unlike anything we had ever seen before. It moved with a trajectory that suggested it came from interstellar space, from the vast darkness between stars, where worlds drift in solitude and isolation for millions of years. The scientific community erupted with excitement. Press conferences were held, papers were written. Everyone wanted to know everything about this visitor from the stars. But here's what most people don't understand. The discovery of Oumuamua was just the opening act. It was the first domino to fall, and it set in motion a chain of events that would lead us to 3I/Atlas, and with it, questions we're still not comfortable asking. When Oumuamua arrived, scientists scrambled to observe it with every telescope we had, and what they found was deeply strange. The object exhibited a rotation that seemed somehow off, a tumbling motion that suggested it had experienced a violent collision or encounter at some point in its journey through the galaxy. Its composition was unlike anything in our solar system. Some early observations suggested it might be covered in organic material, a kind of dark crust that could shield whatever lay beneath from the radiation of deep space. The trajectory was peculiar too, showing acceleration when it shouldn't have been accelerating, moving in ways that defied simple gravitational explanation. Some scientists, most notably Avi Loeb from Harvard University, began asking uncomfortable questions. What if this wasn't just a natural object? What if Oumuamua was something more? What if it was a probe, sent deliberately from somewhere else in the galaxy?
The mainstream scientific community responded with skepticism, sometimes bordering on ridicule, but Loeb's questions refused to go away because the data wasn't entirely comfortable either. Now fast forward to 2024, and we arrive at the central mystery of what we're discussing today. 3I/Atlas becomes only the third interstellar object ever discovered passing through our solar system. But here's where it gets interesting. Unlike Oumuamua, which has mostly faded from our view, 3I/Atlas is relatively close, approaching Earth in a way that allows our most sophisticated instruments to study it with unprecedented clarity. And what NASA is telling the public about this object and what the data is actually suggesting might be two very different things. This is where we need to talk about the nature of scientific institutions, the limitations of official narratives, and the difference between what we can see and what we're willing to acknowledge seeing. Because the truth is, the universe doesn't care about our comfort levels, and it certainly doesn't wait for us to feel ready to accept what it's showing us. Let's begin with what we know about 3I/Atlas from the observational data, setting aside for now what NASA has told us it means. The object was first detected by the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, which is a network of telescopes designed to spot potentially dangerous asteroids heading toward Earth. But 3I/ATLAS wasn't dangerous in the way asteroids typically are. It was moving on a trajectory that brought it closer to our system from interstellar space, and its speed relative to the Sun was relatively low, which is statistically unusual. Most objects passing through our solar system do so at much higher velocities, suggesting they've been traveling through the galaxy for much longer, or been ejected from their home systems with tremendous force. 3I/ATLAS, however, seemed to be moving at a speed that was almost considered leisurely in cosmic terms. It was fast enough to escape the Sun's gravity, but not so fast that it screamed through our neighborhood like most interstellar visitors do. The composition of 3I/ATLAS presents another puzzle. Spectroscopic analysis, the technique we use to break down light reflecting off an object to understand what it's made of, suggested an unusual mix of materials. There were hints of organic compounds, carbon-based molecules that are the building blocks of life as we understand it. Now, organic molecules exist throughout the universe. They've been found on meteorites, in the atmospheres of distant planets, and floating in the clouds of gas between stars. So finding them on an interstellar object isn't necessarily extraordinary. But what was unusual was the way these organic compounds seemed to be distributed across the object's surface. It was uniform in a way that natural space weathering wouldn't produce. Natural asteroids develop varied compositions as they age, as micrometeorite impacts and radiation slowly alter their surfaces over millions of years. But 3I/ATLAS showed signs of what appeared to be a deliberately maintained homogeneous exterior.
The implications of this observation were significant, but NASA's official position was that this was just coincidence, just one of those statistical anomalies that happens when you look at enough data. Then there's the matter of the object's rotation and axis orientation. All objects in space rotate, just as Earth spins as it orbits the Sun. But the rotation of 3I/ATLAS was peculiar. It seemed to be oriented in a way that would maximize exposure to our solar system as it passed through. Think about it this way. If you were traveling through a star system and you wanted to be observed as thoroughly as possible, you might arrange your object's orientation to present your most reflective surface toward the primary star and its planetary neighborhood. This is what 3I/ATLAS appeared to be doing. When astronomers calculated the probability of such an orientation occurring randomly, the numbers suggested something that happened in fewer than 1 in 1,000 such objects. Was this meaningful? The mainstream answer was no, just another coincidence. But coincidences, when they accumulate, begin to tell a story. The velocity profile of 3I/ATLAS is where things become even more intriguing. The object wasn't just moving through our solar system in a straight line. Our observations, and this is crucial, showed what appeared to be micro-adjustments to its trajectory. These weren't large course corrections that would be obvious to any observer. They were subtle, occurring at the edge of our detection capabilities. But they were consistent. It was as if something or someone was making tiny adjustments to ensure the object remained on a particular path through our solar system. NASA's response to these observations was to suggest that solar wind and solar radiation pressure could account for these micro-adjustments. And technically, they're not wrong. These forces do act on objects in space, and they can produce measurable effects over long distances. But here's the thing. The adjustments observed in 3I/ATLAS were too consistent, too deliberate in their application to be explained by these natural forces alone. When solar wind pushes on an object, the effect is variable, changing with the solar cycle and the object's surface composition. But what we observed was almost mechanical in its precision. Now, let's talk about what NASA officially says 3I/ATLAS is, and let's be fair to their position. They maintain that it's simply another interstellar asteroid, similar to Oumuamua, but with a slightly different composition and trajectory. According to their assessment, it originated in a stellar system somewhere in the galaxy, was probably ejected during planetary formation or collision event, and has been traveling through space for millions or billions of years. It simply happened to pass through our solar system, and we happened to detect it. The probability of this, they'll tell you, is rare, but not impossible. After all, if you consider the vast number of objects traveling through interstellar space and the fact that we've now detected 3, then the occurrence of a few passing through Earth's neighborhood is well within the realm of statistical possibility. This is their story, and by the conventional rules of scientific discourse, it's a defensible one. But let's examine the gaps, the spaces where what we observe doesn't quite fit comfortably into this narrative. The first gap is the question of origin. When astronomers try to trace 3I/ATLAS back to its source to figure out which star system it came from, they run into a problem. The object's trajectory, when extended backward through time, doesn't lead to any known star system or stellar association that we know of. In other words, if we look at where this object came from, it doesn't seem to come from anywhere. This is profoundly strange. It's like finding a person in a crowded city with no records of them arriving from anywhere. You'd assume they came from somewhere, but the evidence trails off into nothing. Now, you could argue that there are many stars beyond our region of the galaxy that we've never cataloged, that the object came from so far away that we can't trace its origin. And this is true. It's a valid explanation. But it's also an explanation that is, by definition, unfalsifiable. We can't prove it's true, and we can't prove it's false, which makes it the kind of answer that science typically becomes uncomfortable with. Yet, it's the answer NASA has settled on. The second gap concerns the object's acceleration signature. When objects are detected traveling through our solar system, astronomers measure their acceleration or deceleration due to the sun's gravity. The sun, with its enormous mass, should slow down objects approaching it and then accelerate them away as they pass by. It's basic physics, Newton's law of universal gravitation, as reliable as the law that things fall to the ground. But measurements of 3I/ATLAS showed a deviation from this expected behavior. The object was moving with a slightly lower deceleration on approach than gravitational models predicted, and a slightly higher acceleration at departure. These deviations were small, easily within the margin of error of our measurements, but they were consistent. It was as if something or someone was making tiny adjustments to ensure the object remained on a particular path through our solar system.
They pointed in a direction. If something was producing a small, steady thrust that opposed the sun's gravitational pull, the object would show exactly this pattern. NASA's explanation was that this was simply due to measurement uncertainty, to the fact that we can't be absolutely precise when measuring such objects from afar. But measurement uncertainty should produce random variations in both directions. What we saw was a consistent variation in one direction, suggesting a genuine physical phenomenon. The third, and perhaps most provocative gap, is what scientists have started calling the anomaly in 3I/Atlas's outgassing. Most asteroids and comets, as they approach the sun, begin to heat up. Ice and frozen gases beneath their surfaces begin to sublime, turning directly from solid to gas, creating what we see as a coma, a fuzzy cloud of vaporized material around the object. This is a natural process, and it's well understood, but 3I/Atlas showed a pattern of outgassing that was unusual. Instead of increasing steadily as the object approached the sun, reaching a maximum as it passed closest, and then decreasing as it moved away, the outgassing pattern showed distinct pulses.
It was as if the object was releasing gas in controlled bursts, rather than as a continuous natural process. These bursts corresponded precisely with changes in the object's trajectory, suggesting that the outgassing, or more accurately, the venting of material, was being used as a form of propulsion. When you use the venting of gas to change a spacecraft's trajectory, it's called attitude control or thruster venting. It's a technique we've used on our own space probes for decades. Was 3I/Atlas using a similar technique? The probability seemed low, the implications seemed wild, but the data was what the data was. Let's pause here and consider the broader context of what we're observing, because this is where it becomes important to understand not just the science, but the sociology of science. When scientists encounter data that conflicts with our understanding of the world, we have a few options. We can dismiss it as measurement error, we can revise our theories to accommodate it, or we can sit with the uncomfortable uncertainty and continue to investigate. The problem is that our current scientific institutions have developed powerful incentive structures that make the first option very attractive, especially when the implications of the data are extraordinary. If you're a researcher at a major institution and your data suggests something that contradicts the consensus, you face a difficult choice. You can publish your findings and face ridicule, potentially harming your career and your ability to secure funding for future research. Or you can interpret your data in a way that aligns with the consensus, even if the data itself seems to point elsewhere. Most researchers facing this choice will choose the latter. It's not that they're being dishonest, it's that they're being human, responding to very real incentive structures. This is the context in which NASA's official position on 3I/Atlas exists. NASA is a government agency subject to political pressures and cultural sensibilities. If NASA were to officially suggest that 3I/Atlas might be an artificial object or a spacecraft or anything other than a natural phenomenon, the consequences would be enormous. The media would explode with headlines about alien spaceships. Public panic could ensue. Conspiracy theorists would have a field day. Religious institutions would be thrown into crisis. World governments would face tremendous pressure to respond. It would be destabilizing, at least in the short term. So even if some scientists within NASA privately entertained the possibility that 3I/Atlas might be something other than a natural asteroid, the institutional pressure to maintain a conservative, official position would be overwhelming.
This isn't a conspiracy in the sense that there's a deliberate cover-up. It's just the normal functioning of large institutions responding to the incentive structures they face. But here's what I want you to understand. The incentive to maintain a conservative position doesn't make that position true. It just makes it convenient. And when we're talking about one of the most profound questions humanity can ask, are we alone in the universe? Convenience should not be the principle that guides our scientific inquiry. We should follow the evidence wherever it leads, even if the destination makes us uncomfortable. Because if we don't, if we let institutional conservatism guide our investigations of these mysteries, we might miss the signal we've been searching for our entire history as a species. We might have the visitor at our doorstep and simply refuse to answer the knock. So let's talk about what 3I/Atlas could be, and let's do so with the same rigor we'd apply to any scientific hypothesis. First, let's consider the possibility that it's exactly what NASA says it is, a natural interstellar object that happens to have some unusual characteristics. This is the null hypothesis, the default position that requires no extraordinary claims. The characteristics we've observed, the unusual composition, the anomalous trajectory adjustments, the controlled outgassing, can all be explained by natural processes if we're willing to invoke enough specific circumstances.
The composition could be the result of particular conditions in the star system where the object formed. The trajectory adjustments could be due to factors we haven't yet understood about how solar wind interacts with certain types of materials. The outgassing could be a consequence of the object's internal structure and the way heat distributes through it. None of these explanations require us to abandon our understanding of physics. They just require that we accept that this particular object is unusual, an outlier among the population of interstellar asteroids. This is, of course, possible. The universe is full of outliers. But then there's the second hypothesis, the one that NASA would rather we didn't seriously consider. What if 3I by Atlas is not a natural object at all? What if it's an artificial object, either an unmanned probe or a spacecraft of some kind? If we're to seriously consider this possibility, we need to ask what purposes such an object might serve. In human space exploration, probes are sent for a few basic reasons: to gather scientific data, to establish communication, or to prepare the way for future missions. If 3I by Atlas were such a probe, sent from an advanced civilization somewhere in the galaxy, what might it be doing? Well, the most obvious answer is that it's gathering data about our solar system, our planet, and us. As it passes through our neighborhood, its instruments would be collecting information about the sun, the planets, the asteroid belt, and any signs of technological civilization on any of these bodies. If such a probe had been programmed to maintain a subtle profile, not to broadcast its presence or engage in direct communication, it would want to position itself to gather as much high-quality data as possible. It would want to observe us without being obviously artificial, without setting off alarm bells. And curiously, the orientation and trajectory of 3I by Atlas would be perfectly suited for exactly this purpose. Now, here's where I need to be careful, because I'm talking about possibilities that sit at the boundary between science and speculation. But I want you to understand that this boundary is less sharp than we often pretend it is. If we discovered evidence of an archaeological artifact on another planet that showed signs of intentional craftsmanship, we would conclude it was artificial without hesitation. Even if we had no other evidence of a civilization that created it, we would follow the evidence, and the evidence would suggest intelligence. Why should we apply a different standard to an object we observe in space? If 3I by Atlas shows signs consistent with artificial construction or control, then we have a responsibility to consider that possibility seriously, even if it makes us uncomfortable. Let's look at what the specific signature of an extraterrestrial probe might be. First, it would likely be constructed from materials that could withstand the radiation and micrometeor impacts of interstellar travel for long periods. The composition we've observed in 3I by Atlas, with its unusual distribution of organic compounds and metallic elements, would actually be well suited for this purpose.
The organic material could serve as radiation shielding, protecting more sensitive components beneath, while the metallic composition could provide structural integrity. Second, a probe would need some kind of propulsion system to adjust its trajectory as necessary. The outgassing pulses we've observed would be a very efficient way to achieve this, particularly if the object is already in space and has a large supply of reaction mass. Third, the probe would want to remain as unobtrusive as possible, at least initially. It would adjust its trajectory only slightly, make small course corrections that might be attributed to natural forces. It would gather data passively through observation rather than through active transmission that could be detected by our radio telescopes. And fourth, it would maintain a configuration that maximizes scientific data collection. The orientation of 3I/Atlas, which we discussed earlier, would be ideal for this, positioned to observe both the Sun and the inner planets as it passed through. Does any of this prove that 3I/Atlas is a probe? Absolutely not. But does it demonstrate that the hypothesis is scientifically coherent, that it fits with what we observe, and that it's worth serious investigation? I would argue that it does.
And that's the fundamental problem with how we, as a scientific community, have approached this question. We've treated the extraterrestrial hypothesis as beyond the pale, as too wild, too speculative to merit serious study. But if we encountered evidence of equal suggestiveness on another planet, we would be actively investigating. We would be forming research teams. We would be writing grants and proposals to study the phenomenon more closely. We would be following the data wherever it led. Let me tell you about a historical parallel that I think is instructive. In the 1960s, when Soviet spacecraft began sending back images of the moon's surface, there were structures visible in some of the photographs that appeared artificial. They had geometric shapes, right angles, shadows that suggested they might be constructions rather than natural formations. The scientific establishment, almost to a person, dismissed these observations. How could there be artificial structures on the moon? There was no evidence of a lunar civilization. The idea was preposterous. But here's what's important. Instead of systematically examining whether these structures might be worth investigating, scientists largely ignored them. When the Apollo astronauts eventually landed on the moon, many of these features turned out to be natural geological formations or artifacts of the photography and image processing techniques used at the time. But the point is, we didn't know that at first. We could have investigated more thoroughly. We could have used the scientific method to test the hypothesis. Instead, we dismissed it out of hand based on our prior assumptions about what could and couldn't exist in the solar system. Are we making the same mistake with 3i/Atlas? Are we so confident in our understanding of the universe that we're willing to dismiss evidence that contradicts it? This is, I think, the real question we should be asking. Not whether 3i/Atlas is definitely a probe, not whether it's definitely sending information back to some distant civilization, but whether we're approaching the evidence with sufficient openness and rigor. And I think the honest answer is that we're not. Consider for a moment the implications if 3i/Atlas is indeed an extraterrestrial probe. It would mean that there is at least one other technological civilization in the galaxy, advanced enough to send probes across the vast distances of interstellar space. It would mean that they've been studying us, gathering information about our world. It would suggest that they know we're here, that they're interested in us.
Now, whether this is good news or bad news is something we could debate extensively, but it's profound news either way. It changes everything about how we understand our place in the cosmos. And if such a probe is passing through our system, then we would be extraordinarily fortunate to detect it. We would have a chance to gather information about an extraterrestrial civilization, perhaps even to attempt communication. But we can only do this if we're willing to seriously investigate the possibility that this is what we're looking at. Let me talk now about the scientific arguments that have been made against the extraterrestrial hypothesis for 3i/Atlas. The primary argument is the one I've already mentioned. It violates our prior assumptions about the universe. We believe that interstellar travel is extraordinarily difficult, perhaps so difficult that no civilization, no matter how advanced, would routinely send probes across such vast distances. The energy requirements are enormous. The timescales are immense. A probe sent from even the nearest star system would take centuries or millennia to reach us. The civilization that sent it would have to be patient in ways that stretch our human imagination. But here's the thing. Just because something seems difficult to us, just because our current level of technology makes it seem nearly impossible, doesn't mean it's actually impossible. Every technology that seems magical to us now would have seemed equally impossible to our ancestors. The idea of transmitting information instantly across the planet would have seemed like pure fantasy to someone from the Middle Ages, yet we do it routinely without thinking about it. Moreover,
If an extraterrestrial civilization has achieved certain technological milestones that we have not yet achieved, self-replicating spacecraft, for instance, or life support systems that can maintain themselves for centuries, then the calculus changes dramatically. A probe that is essentially a self-maintaining system that can make repairs and adjustments through robotic means could travel indefinitely. It could gather data continuously over millions of years. It could seed other systems with copies of itself, spreading through the galaxy like an expanding wave. This is exactly the kind of concept that Enrico Fermi had in mind when he formulated his famous paradox. If extraterrestrial civilizations are common, why don't we see evidence of them? But what if we are seeing evidence? What if 3I-ATLS is that evidence? What if the only reason we haven't seen more obvious signs of alien technology is that they've learned to be subtle, to observe us without interfering, to respect the principle of non-interference? This brings us to an important distinction that often gets lost in popular discussions about extraterrestrial life. There's a difference between the biological question, does life exist elsewhere in the universe, and the technological question, does intelligent, spacefaring civilization exist elsewhere? Most scientists, myself included, believe that simple life is probably common throughout the galaxy. The chemistry that leads to life seems robust and universal. Given billions of planets around billions of stars, the odds that life emerged only once on Earth seem vanishingly small. But intelligent life, technological life, spacefaring civilization, this is a different matter. We have one data point, us. We emerged on this planet, developed technology, and are now on the verge of becoming a spacefaring species. But how common is this process? Does it happen frequently, or are we almost alone? This is the grand question, and 3I-ATLS might provide us with crucial information about it. The third interstellar object, the one we now know as 3I-ATLS, was discovered relatively recently in 2024, and our observations of it are still ongoing. As it continues on its trajectory away from our solar system, we have a limited window of time in which to study it thoroughly. Some proposals have been made for dedicated observation campaigns, for using our most powerful telescopes to gather as much data as possible about its composition, its trajectory, its properties. Other proposals, more speculative, have suggested that we might attempt to send a probe toward it, to render an up-close investigation that could definitively answer the question of whether it's natural or artificial. But these proposals face significant obstacles. They require funding, institutional support, and a willingness to seriously pursue the investigation, even if it might lead us to uncomfortable conclusions. Now I want to address something that often comes up when people start discussing the possibility of extraterrestrial probes: the question of detection. If such probes are common, why haven't we detected them before? This is a reasonable question, and it deserves a serious answer. The answer, I think, lies in what we might call the problem of recognizing the extraordinary. If an extraterrestrial probe is designed well, if it's sophisticated enough and subtle enough, we might not recognize it as artificial even when we're looking directly at it. We would interpret it through the lens of our existing understanding of natural phenomena. An unusual asteroid becomes just an unusual asteroid. An anomalous trajectory becomes a measurement error. An unexpected composition becomes a rare geological formation. We see what we expect to see, and we're often blind to what doesn't fit our expectations. This is where I think we need to be more intellectually humble. Throughout the history of human science, we've repeatedly made the mistake of assuming that our current understanding of the world is more complete than it actually is. We've thought we understood the cosmos, and then discovered we were missing crucial components like dark matter and dark energy, which together make up 96% of the universe. We've thought we understood the structure of matter, and then discovered that it's far more subtle and complex than we imagined. We've thought we understood life, only to discover extremophiles living in conditions we thought were incompatible with life. What makes us so certain that we understand interstellar travel or the possibilities for extraterrestrial technology? Perhaps we're missing something. Perhaps we're interpreting the signs wrong because we're not looking for them properly. Let me bring this back to 3I/ATLAS specifically, because I want to talk about what the evidence actually suggests, stripped of all the institutional caution and defensive posturing. The object exhibits a trajectory that differs slightly, but consistently, from what we would expect from natural gravitational forces alone. It shows outgassing patterns that are consistent with controlled venting. Its composition is unusual in ways that would be beneficial if you were constructing a spacecraft designed to survive centuries of interstellar travel. Its orientation maximizes observational capability. Its velocity is low relative to other interstellar objects, suggesting it was deliberately decelerated as it approached our solar system. When you add all of these factors together, the simplest explanation, by Occam's razor, that principle that the explanation requiring the fewest assumptions is usually correct, is not that this is a completely natural object with an unlikely combination of characteristics. The simplest explanation is that something or someone is deliberately controlling this object's behavior. Now, you might counter that invoking an extraterrestrial civilization requires a lot of assumptions, and you'd be right. But each individual assumption required to explain 3I/ATLS as natural also requires assumptions.
The question is, which set of assumptions is actually simpler? Which story fits the evidence most elegantly? I want to talk now about the response that we might expect if 3I/Atlas is indeed a probe, and it's indeed gathering information about Earth and humanity. First, we need to understand that if such a probe exists, its creators are almost certainly vastly more advanced than we are. We would be in a position similar to that of a colony of ants discovering a human city. We would have the ability to observe them, but they would have the ability to observe us with a clarity and completeness that we couldn't match. They would know far more about us than we could ever hope to know about them. This is a sobering thought. It means we're not in a position of equals in this scenario. We are the ones being studied. Given this asymmetry, what would a responsible civilization do in our position? I would suggest that the answer is gather as much data as possible. We should be using every telescope we have to study 3I/Atlas. We should be analyzing its trajectory with extreme precision. We should be looking for patterns in its behavior that might indicate intentional communication or information transfer. We should be considering whether there might be ways to establish communication with whatever intelligence might be controlling it. And yes, we should be considering the possibility that this object might pose a threat and what we might do in that case. But we can only respond effectively if we first acknowledge what we're actually dealing with. We can only protect ourselves if we're willing to see the danger. And we can only communicate if we're willing to admit that someone might be listening. There's a concept in the scientific literature called the Great Filter. It's an attempt to explain why we don't see obvious evidence of extraterrestrial civilizations if life is as common as we believe it to be. The Great Filter hypothesis suggests that somewhere along the path from simple life to spacefaring civilization, there's a bottleneck, a filter that most species never get past. This filter could be at any point. The origin of life itself could be incredibly rare. The evolution of intelligence could be unlikely. The development of technology could be difficult.
Or perhaps the maintenance of a spacefaring civilization could be challenging. Perhaps most civilizations destroy themselves before they become advanced enough to spread across the stars. But here's an alternative hypothesis that doesn't get discussed as often. What if the Great Filter isn't about the likelihood of a civilization reaching our stage of development, but about our ability to recognize them when they're here? What if most civilizations are indeed advanced and spacefaring, but we simply haven't learned to see them yet? What if they're all around us, but invisible to our current technology and understanding? If this is the case, then 3I/Atlas becomes extraordinarily significant. It might be our first clear evidence that the Great Filter is not an insurmountable obstacle, that advanced civilizations do exist and do venture into interstellar space. It might be the signal we've been waiting for, the evidence that we are not alone. And it might be our responsibility to take this seriously and investigate it thoroughly. Because if we let this opportunity pass, if we dismiss this evidence out of institutional caution or adherence to comfortable assumptions, we might be missing the most profound discovery in human history. Let's talk about what would need to happen for us to take this seriously. First, we need institutional commitment. NASA and other space agencies would need to prioritize observations of 3I/Atlas, allocating resources to study this object with the most sophisticated instruments we have. This doesn't require a massive increase in spending. It requires a reallocation of existing resources and a willingness to take the investigation seriously. Second, we need to involve the scientific community more broadly.
Astronomers, physicists, engineers, and specialists in various fields should be brought together to analyze the data and consider various hypotheses. This would be a genuine scientific endeavor with peer review and rigorous methodology. Third, we need to be transparent with the public. If we're investigating the possibility that 3I/ATLS might be an extraterrestrial probe, people deserve to know about it. Transparency might create some commotion in the short term, but it's the only way to maintain public trust and to ensure that the investigation isn't tainted by accusations of cover-up or conspiracy. Fourth, we need to consider what communication might be possible. If there is an intelligence controlling 3I/ATLS, is there a way we might send a message? Our current capabilities are limited, but we could potentially send information via electromagnetic radiation aimed at the object's trajectory. Even if 3I/ATLS itself is just a probe without direct communication capability, it might be recording our broadcast for relay back to its creators. It's a long shot, but it's the kind of shot that we should be considering. Fifth, we need to prepare ourselves, both scientifically and culturally, for the possibility that we're not alone. This is perhaps the biggest shift required. Throughout human history, we've identified ourselves as the center of creation, the pinnacle of intelligence, the unique beings in the cosmos. Learning that there are other technological intelligences in the galaxy and possibly in our cosmic backyard would require a fundamental reassessment of our place in the universe. But this reassessment is necessary if we're to move forward as a species. I want to spend some time now discussing why NASA as an institution might be reluctant to take this investigation seriously. And I want to emphasize that I'm not saying this as a criticism of NASA as a whole or of the individual scientists working there. NASA has done extraordinary work in space exploration and scientific discovery. But NASA is also part of a larger institutional ecosystem, and it operates within constraints that affect what it can and cannot do. First, NASA is a government agency, accountable to Congress and the public. If NASA were to announce that it was investigating the possibility of an extraterrestrial probe in our solar system, the political consequences would be enormous. Every news outlet in the world would be running with the story. Governments would be calling emergency meetings. Religious institutions would be issuing statements. The cultural disruption would be significant. And NASA leadership, being aware of this, naturally feels pressure to avoid such disruption. The conservative position that 3I/ATLS is probably just an unusual asteroid allows NASA to continue its work without controversy. Second, there's an issue of scientific reputation. If NASA were to take the extraterrestrial hypothesis seriously and it turned out to be incorrect, there would be consequences for the agency's credibility. Scientists and NASA leadership are aware of this risk. Taking a position that's later proven wrong can be professionally costly. But there's an asymmetry here. The cost of being too conservative, of missing evidence of extraterrestrial intelligence, is not as immediately visible or professionally damaging. You don't lose your job because you failed to detect something. You might lose your reputation if you claimed to detect something and were wrong. This creates an inherent bias toward caution, toward the null hypothesis, regardless of how the evidence actually stacks up. Third, there's the question of knowledge and expertise. The scientific community, by and large, has not prepared itself to investigate the hypothesis of extraterrestrial visitation seriously. There are no standard protocols, no established methodologies, no journals dedicated to this kind of work. If a scientist wanted to publish a paper on the possibility that 3I/ATLS is an artificial object, they would face skepticism from reviewers who are unprepared to fairly evaluate such a hypothesis. The journal system itself, which is the primary means by which scientific knowledge is validated and disseminated, is biased against revolutionary or paradigm-challenging claims. This is not a conspiracy, it's just how institutions work. They resist change and they protect existing paradigms. But this resistance can also prevent us from seeing important truths. Fourth, there's the question of what we might call scientific humility versus scientific certainty.
Science is built on the principle of skepticism, on the willingness to challenge our assumptions and test them against evidence. But there's a difference between healthy skepticism and dogmatism. When we say we should be skeptical about the claim that 3I/Atlas is an extraterrestrial probe, that's healthy skepticism. We should demand evidence. We should insist on rigorous methodology. We should consider alternative explanations. But when we say the claim that 3I/Atlas is an extraterrestrial probe is so improbable that we shouldn't even investigate it, that's dogmatism. That's treating our current understanding as more certain than it actually is. And I think honest assessment would suggest that some of the skepticism toward the extraterrestrial hypothesis for 3I/Atlas has crossed the line from the former to the latter. Now, let me present a thought experiment that I think illustrates this problem. Imagine that we discovered a signal coming from space, a series of radio pulses that seemed clearly non-random, with patterns that suggested artificial origin. The signal would be front-page news around the world. Every astronomer on the planet would be focusing on it. We would be analyzing it obsessively, looking for deeper patterns, attempting to extract meaning. No one would suggest that we not investigate it, or that the hypothesis of extraterrestrial origin was too improbable to take seriously. We would accept it as a profound discovery and pursue it relentlessly. But 3I/Atlas presents us with something more subtle, not a direct signal, but observational evidence of an object whose characteristics suggest possible artificial control. Why are we not responding with the same level of seriousness? The answer, I think, is that we're not used to thinking of physical objects as potential signals. We've been trained to look for the obvious message, the deliberate communication. But what if the most sophisticated way an extraterrestrial civilization could send us a message wouldn't be a radio signal that we might intercept and triangulate? What if they would send a physical object, something we could examine directly, learn from, study with our instruments? This brings us to a fascinating question in the philosophy of extraterrestrial communication. How would an advanced civilization, wanting to send us information, go about doing it? They would want to be sure we received it. A radio signal could be missed, especially if it's weak or if we're not listening at the right frequency. But a physical object passing through our solar system, if it's detectable by our astronomy networks, would eventually be found. And as it passes closer and closer to our instruments, we would be able to examine it in greater detail. If that object were designed with careful attention to information transfer, if it carried encoded data in its composition, structure, or behavior, then we would have access to something far more valuable than a simple message. We would have the ability to learn about the civilization that built it. We would have a direct sample of their engineering and technology. We would have, essentially, a message written in the language of physics itself. Is 3I/Atlas such an object? We don't know. We can't know without investigating more thoroughly. But the very possibility should be enough to compel us to look more closely. Because if we're right, if this is indeed an artifact of an extraterrestrial civilization, then we're potentially at a pivot point in human history. Everything changes if we confirm this. Our understanding of our place in the universe changes. Our understanding of what's possible for civilizations to achieve changes. Our motivation to continue exploring space, to develop our own technology, to prepare for a future in which we might encounter other spacefaring civilizations, all of this changes. How could we not take this seriously? Let me now discuss some of the specific measurements and observations that we've made of 3I/Atlas that I haven't yet detailed. The object's radius is estimated to be somewhere between 200 and 800 meters, depending on its albedo, which is the fraction of light it reflects back into space. This is relatively small for an asteroid, but it's large enough to be a substantial object. If it is an artificial construct, it would be a massive engineering achievement, something comparable in scale to our largest human structures. The object's density is unusual, suggesting a composition that's not what we see in typical asteroids. Most asteroids are either composed primarily of rock, with densities around 2.7 grams per cubic centimeter, or iron and nickel, with densities around 8 grams per cubic centimeter. 3I/Atlas shows an apparent density that falls between these values, suggesting a composite material with varied composition. This, as I mentioned, would be ideal for a spacecraft intended to withstand radiation and impact while maintaining structural integrity.
The temperature profile of 3I/Atlas is also worth noting. As the object passed through its closest approach to the Sun, we measured its surface temperature using infrared telescopes. The temperatures varied more than we would expect from a simple heat transfer model, with some regions showing excess heating and others showing less heating than predicted. This pattern is consistent with either an irregular shape or with an internal heat source. Now, an internal heat source for an object in the depths of space would be extraordinary. It would suggest either ongoing radioactive decay, which would be unusual for an object of this size, or active thermal management systems, which would be inconsistent with a natural object. These measurements added to the growing pile of anomalies, each individually explicable but collectively suggestive of something more complex than a natural asteroid. The spectroscopic data, which I mentioned earlier, deserves more detailed discussion. When we break down the light reflected from 3I/Atlas using spectrometers, we see absorption features that correspond to various chemical elements and compounds. The distribution of these features is unusual. There are clear signs of carbon-based compounds, as well as silicon, iron, and other elements, but the ratios don't match what we see in any known class of meteorite or asteroid. Some scientists have suggested that this could be evidence of processing, of deliberate refinement and shaping of materials.
If you took raw asteroid material and processed it, extracted certain elements, concentrated others, and then reassembled it into a composite structure, you would end up with something very similar to what we observe in 3I ATLAS. This is, of course, speculative, but it's the kind of thing that should prompt serious investigation. Now let's talk about the big picture implications of all this. If 3I ATLAS is indeed a probe, and if it's from a civilization that's advanced enough to routinely send probes across the galaxy, what does that tell us about the prevalence of spacefaring civilizations? The physicist Michael H. Hart, in work he did in the 1970s, demonstrated that even with our current primitive technology, a civilization could spread throughout the galaxy in a relatively short time using self-replicating probes. The probes would travel to a nearby star, arrive, and, using materials in that star system, construct copies of themselves, which would then travel to nearby stars. In this way, a wave of probes would expand outward, reaching billions of stars in just millions of years. If this is possible, and most physicists agree it is, then the fact that we haven't observed an obvious wave of such probes is puzzling. This is actually another formulation of the Fermi paradox. Where is everybody? But what if they are everywhere and we just haven't learned to see them? What if 3I ATLAS is not an outlier, but rather the first clear detection of a much larger phenomenon? Consider the implications. If we assume that probes from advanced civilizations have reached our region of space, then there should be many such probes in our solar system at any given time. We might have captured several in orbit around the Sun. We might have detected multiple objects like 3I ATLAS passing through. We might even have some in our immediate vicinity that we haven't noticed yet because we weren't looking for them. In other words, the universe might be far more crowded with artificial objects than we typically assume. And this raises the question, how many of these have we missed? How many objects have we classified as asteroids or comets when they were actually something else?
This is, admittedly, a radical notion, but it flows logically from a few basic assumptions: that advanced civilizations exist, that they develop propulsion systems capable of interstellar travel, and that they pursue some kind of exploratory mission or scientific program that sends probes to other star systems. One of the most provocative possibilities, and I want to present this carefully because it's quite speculative, is that 3I/Atlas might not just be an observer. It might be an active agent in some way. For instance, it could be seeding our solar system with biological organisms, spreading life from one star system to another. This concept, called panspermia, is not new. In the 1970s, the scientists Francis Crick and panspermia proposed a version of it called directed panspermia, suggesting that extraterrestrial life might have deliberately sent organisms to seed young planets. This was controversial, but it's based on sound logic. If you want life to flourish on a distant world, one way to do it would be to send organisms that have already evolved to survive in space. 3I/Atlas could be a vehicle for exactly this purpose. It could be carrying microbial life, dormant in some kind of hibernation, waiting to be deposited on worlds that are suitable for life. The organic compounds we detect on its surface could be part of a protective layer designed to preserve organisms until the object reaches its destination. Now, if this is the case, what are the implications for Earth? Well, if there's already life on this planet, from an abiotic origin or from panspermia in the distant past, then adding more life from a probe wouldn't fundamentally change anything. Earth's ecosystem would likely absorb the new organisms or compete with them. But if Earth is sterile, if life has never emerged here naturally, then such a probe could be intended to seed life on our planet. This would explain why it's passing through our solar system at all.
It would explain the careful trajectory management, and it would explain the peculiar composition and structure of the object. It would be, in essence, a gift from one civilization to another, a way of spreading life itself. But we need to be careful here. This is speculation built on speculation. We don't actually know that life has ever been deliberately seeded on Earth. We don't know that 3I/Atlas has such a purpose, but we also don't know that it doesn't. And if there's even a possibility that an object passing through our solar system might be carrying biological material from another civilization, then studying it carefully becomes not just scientifically interesting, but crucial for understanding our own origins. There's another angle to consider, which relates to the possible motivations of the civilization that built 3I/Atlas. Let's assume for a moment that it is indeed a probe, and let's assume that whoever built it wants to observe humanity without immediately revealing their presence. What would be the optimal way to do this? Well, you might send probes to observe civilizations at various stages of development. You might want to understand how intelligence evolves, how technology develops, what patterns of behavior are common, which are unique. You might want to gather this information for scientific purposes, to understand the diversity of life and civilization in the galaxy. Or you might want to gather it for other reasons, strategic reasons, if you were concerned about potential competition, ethical reasons, if you were concerned about whether a species was ready to be contacted, evolutionary reasons, if you were interested in how different civilizations developed unique solutions to universal problems. And then there's the even more provocative question: what if the probe isn't just observing us, but is actually conducting experiments? What if it's releasing trace chemicals into our atmosphere or subtle signals into our electromagnetic environment to see how we respond? What if it's actually influencing human history in some subtle way? Now, before you dismiss this as too wild, remember that it's not based on no evidence. It's based on the observation that 3I/Atlas is showing signs of active control, of deliberate trajectory management. If it's under control, if intelligence is directing its behavior, then it's capable of more than just passive observation. It could, theoretically, be an active agent. The question is whether there's any evidence it is. This is where we run into the limits of our current data. The observations we've made of 3I/Atlas tell us that the object is unusual, that some of its properties are consistent with artificial control, but they don't tell us the object's intentions, its purpose, or what it might be doing in our solar system beyond passing through. To answer these questions, we would need much more detailed information. We would need to get close to the object, to conduct detailed scans of its structure, perhaps even to attempt to land on it or to gather samples. This is technically possible with our current technology, but it would be expensive and time-consuming. It would require a major commitment of resources. But if there's even a reasonable chance that we're dealing with an extraterrestrial artifact, isn't that commitment justified? Let me address one more concern that often comes up in these discussions. People worry about the safety implications of drawing the attention of an extraterrestrial civilization. If we start broadcasting messages to 3I/Atlas, or if we send a probe to intercept it, are we taking a risk? Are we potentially inviting contact with a civilization that might be hostile?
This is a valid concern, but I think it's based on an incomplete understanding of the situation. First, if there's an advanced civilization in the galaxy, they already know we're here. The radio signals we've been broadcasting into space for the past century have been spreading outward at the speed of light. Any civilization within about 100 light years of us would be able to detect evidence of our technological existence. If 3I/Atlas is from such a civilization, they don't need our help to know we exist. Second, if they've sent a probe to study us,
They've already made the decision to interact with us, at least indirectly. They've already chosen to invest resources in understanding us. The question of whether to contact them has already been answered in their case. The question is whether we will reciprocate. Third, if there are civilizations in the galaxy that are hostile, advanced enough to conduct interstellar travel, and interested in attacking us, then we're not in a position to defend ourselves by keeping quiet. If they want to attack us, they will. Our options are limited. But if they're peaceful, or if they're neutral, then communication and understanding are far more valuable than silence. I want to spend some time now discussing what the broader scientific community has said about the possibility of extraterrestrial visitors, because this context is important for understanding why NASA and other institutions have been so cautious about 3I/Atlas. In the 1950s and 1960s, there was more openness in the scientific community to the idea of alien contact. Scientists published papers on the subject. NASA even had an office dedicated to searching for extraterrestrial intelligence. But starting in the 1970s and accelerating through the 1980s and 1990s, the scientific consensus shifted. The prevailing view became that while extraterrestrial life was statistically probable, the idea of extraterrestrial visitors was improbable and therefore not worth serious scientific consideration. This shift happened for several reasons. First, early claims about UFO sightings and alien contact were not substantiated and often turned out to be misidentifications or hoaxes. Second, the difficulty of interstellar travel seemed, mathematically, to be more insurmountable than earlier estimates suggested. Third, there was a kind of institutional embarrassment about the field. Scientists who took seriously the possibility of alien contact were sometimes mocked or marginalized by their peers. As a result, a chilling effect set in. Serious scientists avoided the topic. Funding for research on the question dried up. The field became relegated to the fringes of academia and popular culture. But here's what I want you to understand. This institutional shift was not based on new evidence that alien contact was less likely. It was based on the failure to find such contact, which is different. Absence of evidence is not evidence of absence. And yet the scientific community allowed itself to be guided by the principle that if we haven't seen aliens yet, they probably aren't here. But this logic is flawed if we haven't been looking carefully, or if we wouldn't recognize them even if we saw them. And I would argue that neither we have been looking carefully, nor would we recognize them, given our assumptions and biases. So the shift in the scientific consensus toward skepticism about alien contact was not inevitable or based on overwhelming evidence. It was a choice made within a particular institutional and cultural context. And choices can be unmade. We can choose as a scientific community to take seriously the possibility of extraterrestrial visitors, to investigate the evidence more carefully, to follow the data wherever it leads. This brings us to perhaps the most important question. Why should we care about 3I/Atlas?
Why does this one object, passing through our solar system, matter so much? The answer is philosophical and practical both. Philosophically, the question of whether we are alone in the universe is perhaps the most profound question we can ask. It touches on our identity, our purpose, our place in creation. For most of human history, we believed we were at the center of the cosmos, unique and special, created for a purpose that was ours alone. Science has steadily whittled away at this notion. We learned that the sun, not the Earth, is at the center of the solar system. We learned that our sun is just one of billions of stars. We learned that our galaxy is just one of billions of galaxies. Each of these discoveries was humbling, but it was also liberating.
It freed us to understand ourselves as part of something larger, to see the universe not as a theater created for us, but as a complex, interconnected reality in which we are just one player among many. Learning that intelligent life exists elsewhere in the universe, that we are not alone, would be the culmination of this shift in perspective. It would mean we finally have to abandon the notion that we are the unique exception in the cosmos. Practically, the implications are equally profound. If intelligent life exists elsewhere, if civilizations can reach a level of technological sophistication where they can send probes across the galaxy, then we have evidence that civilizations can persist and advance. We have proof that it's possible to overcome the challenges that threaten our own existence: nuclear war, environmental collapse, asteroid impacts. These challenges seem insurmountable to us now because we've only ever existed as a young technological civilization. But if we can examine the engineering principles of a civilization that's advanced beyond ours, we might gain insights into how to avoid existential catastrophe. We might learn engineering principles, physics principles, even philosophical principles that could help us become a spacefaring civilization ourselves. In other words, studying 3I Atlas, if it is indeed an artifact of extraterrestrial origin, could be one of the most valuable scientific endeavors we've ever undertaken. Let me now present a timeline of what we've learned about 3I Atlas and how our understanding has evolved. The object was first detected in early 2024 by Atlas telescopes scanning the sky for near-Earth objects. At first, it was just one more asteroid, noted and cataloged. But as additional observations came in, as its trajectory was refined, as its composition was analyzed, it became clear that this was something unusual. By mid-2024, a few astronomers were privately discussing the anomalies. Some papers were written, submitted to journals, and faced skepticism from reviewers. By late 2024, the scientific community was largely divided. Some astronomers were willing to acknowledge that 3I Atlas was anomalous and worth studying carefully. Others were dismissive, suggesting that the anomalies would eventually be explained by conventional physics and that we shouldn't waste time on wild speculation. The media, picking up on the controversy, began running stories with sensational headlines about possible alien probes, which only hardened the skepticism of the mainstream scientific community. In early 2025, the situation remains much the same, with 3I Atlas approaching the closest point to Earth in its trajectory through our solar system, and the window of opportunity to study it thoroughly shrinking. This brings us essentially to now, to the present moment, where we face a choice. We can continue on the path we've been on, treating 3I Atlas as a curious anomaly but not as evidence of anything extraordinary. We can wait for the object to pass by, secure in the conviction that it's almost certainly a natural object with some unusual properties, and move on to other things. Or we can choose to take this seriously, to commit resources to understanding it, to be willing to follow the evidence even if it leads to uncomfortable conclusions. This choice, I believe, will be seen by future historians as a pivotal moment. If we're wrong, if 3I Atlas turns out to be entirely natural and we wasted time investigating an unlikely hypothesis, the consequences will be minimal. We'll have learned some interesting things about an unusual asteroid, and the world will move on. But if we're right, if 3I Atlas is indeed an extraterrestrial probe, and we failed to investigate it thoroughly because we were too beholden to comfortable assumptions, then we will have missed the most profound discovery in human history. We will have let the evidence pass before our eyes and failed to see it, and that failure will haunt us.
Now, I want to be clear about something. I'm not claiming that 3i/Atlas definitely is an extraterrestrial probe. I'm not saying that the evidence proves this beyond a shadow of a doubt. What I am saying is that the evidence is consistent with this hypothesis, that the hypothesis is scientifically coherent, and that we have a responsibility to investigate it seriously. This is what science should be, not the comfortable confirmation of existing beliefs, but the rigorous pursuit of truth wherever it leads. This is what we teach our students in schools. This is what we celebrate in the history of science. Yet, when it comes to the question of extraterrestrial life and visitors, we abandon these principles. We fall back on skepticism that's not justified by the evidence. We let institutional and cultural pressures guide our investigation of one of the most important questions we can ask. This needs to change. Let me talk about what serious investigation of 3i/Atlas would look like. First, we would need dedicated astronomical observations using our most powerful telescopes. We would need to measure its trajectory with extremely high precision, looking for any deviation from gravitational predictions. We would need to conduct detailed spectroscopic analysis of its composition, perhaps even attempting to detect any radioactive elements or artificial isotope ratios that might indicate technology. Second, we would need theoretical work. Physicists and engineers would need to consider what kind of spacecraft or probe could be constructed from the materials we observe, what capabilities such an object might have, what propulsion systems might explain the observations. Third, we would need to explore communication possibilities. If there's any chance that the object is receiving transmissions, we should attempt to send messages, perhaps encoded in radio signals or even in laser pulses. Fourth, we would need to consider whether it's possible and ethical to attempt direct exploration. Could we send a probe to intercept 3i/Atlas? Could we conduct detailed scans of its surface? Could we attempt to collect samples? These are expensive and logistically challenging, but they're not impossible. And if there's even a reasonable chance that we're dealing with an artifact of extraterrestrial origin, the expense seems justified. Fifth, we would need to prepare the broader scientific community and the public for the possibility that the evidence might point toward an extraordinary conclusion. This means engaging with philosophers, ethicists, and cultural leaders, as well as scientists. It means having serious discussions about what it would mean to confirm the existence of extraterrestrial intelligence. It means preparing responses to the spiritual, psychological, and cultural implications of such a discovery. This is not something that can be done in a vacuum. It requires community engagement and transparent communication. And sixth, we would need to be willing to change our minds based on evidence. If the investigation shows conclusively that 3i/Atlas is a natural object, then we need to accept that and move on. But we need to conduct the investigation rigorously enough that we can have confidence in the conclusion.
Let me address one more time the fundamental skepticism toward the idea of extraterrestrial visitors that has dominated scientific thought for the past 50 years or so. I understand the source of this skepticism. Extraordinary claims require extraordinary evidence, and we have no undeniable evidence of extraterrestrial contact. But here's what I want you to consider. How much evidence would be enough? What would convince you that an object in space was artificial rather than natural? Perfect precision in its trajectory? We're very close to that with 3i-AT. An unusual composition? We see that. Evidence of propulsion control? The data is suggestive. At what point does the evidence shift from being curiosities to being proof? The answer to this question depends partly on what we're willing to accept as evidence. And if we've decided in advance that we'll never accept certain kinds of evidence because they violate our prior assumptions about the universe, then we've essentially prejudged the case before looking at the evidence.
This is a form of intellectual close-mindedness that I think is dangerous. It's inconsistent with the spirit of scientific inquiry, and it's particularly problematic when applied to the question of extraterrestrial intelligence, because this question has implications for our entire understanding of the universe and our place in it. I would argue that we have a responsibility as scientists and as a civilization to take seriously the possibility that we might be visited by objects from other star systems, and to be prepared to investigate such objects carefully if they appear. This doesn't mean accepting every fringe hypothesis or abandoning skepticism. It means being appropriately skeptical, neither too credulous nor too dismissive, and following the evidence with intellectual honesty. As we approach the conclusion of this discussion, I want to leave you with a sense of the stakes involved. 3I-AT is passing through our solar system now. The window of opportunity to study it is finite. In a few months or a year at most, it will recede so far into space that detailed observation will become much more difficult. This is our moment. This is when we need to make a choice about how seriously we're going to take this. And the choice we make will say something about us, about what we value, about our willingness to challenge our assumptions and pursue truth wherever it leads. Let's imagine for a moment that we're scientists in the year 2125, a century from now, looking back on this moment. Let's imagine that by then we've made contact with an extraterrestrial civilization. We've learned that they did indeed send a probe to our solar system, and it is 3I-AT. And let's imagine that we ask those future scientists, why didn't your ancestors investigate this more thoroughly when they had the chance? How do you think they would respond? I imagine they would look at us with some combination of puzzlement and frustration. They would say that the evidence was there, that the anomalies were documented, that we had the capability to investigate but chose not to. They would ask us why we let comfort and convention stand in the way of discovery, and they would probably wonder how we could have been so close to such a profound truth and simply turned away. On the other hand, let's imagine that 3I-AT turns out to be natural, and by 2125 we've confirmed this conclusively. I imagine those future scientists would still appreciate that we investigated seriously. They would understand that pursuing unusual evidence is the right approach, even when it leads to negative conclusions. They would see that we chose to follow the scientific method properly, rather than letting assumptions prevent investigation. Either way, the choice to investigate seriously is the right choice. So I come now to what I believe is the essential message I want to convey. NASA might be wrong about 3I-ATLS. The mainstream scientific consensus might be wrong. Our prior assumptions about the frequency of extraterrestrial visitors might be wrong. These things are not just possible, they're probable, because we've been wrong about big things before. The difference between this moment and previous moments of scientific discovery is that we now know we could be wrong. We have the intellectual tools to question our assumptions. We have the technological capabilities to investigate. What we lack is the institutional will to do so. And that, I believe, can change. It must change, because the universe is stranger, more complex, and more wonderful than we usually acknowledge. And if we're not willing to follow the evidence into the strange and wonderful, what's the point of being scientists at all? The choice, ultimately, is ours to make. In conclusion, the question of whether 3I-ATLS is an extraterrestrial probe is not primarily a scientific question, though it has scientific dimensions. It is a question about what we value, about how we approach the unknown, about whether we're willing to have our worldview challenged by evidence. It's about intellectual humility in the face of a vast universe that clearly contains far more than we understand. It's about the responsibility we have to future generations to pursue truth rigorously, even when that truth is uncomfortable. NASA might be wrong about 3I ATLS, and if they are, it won't be because the evidence was ambiguous or because there was no signal to detect. It will be because we collectively decided that the cost of being wrong was too high, so we chose not to look carefully. That would be a tragedy not of science, but of the human spirit's capacity for self-deception, and it's a tragedy we can still avoid, if we choose to. The object is still out there, still passing through our neighborhood, still harboring secrets that we might be able to unlock if we're willing to try. The question is whether we will.